Here we have a bunch of graphs in yellow. And these graphs are all intended to depict shifted and stretched functions, basic functions. The y equals x squared, 1 over x, 1 over x squared, x cubed, and 2 to the x functions. So, which graph goes with which? Well, the graphs have rather distinctive shapes. It's pretty clear that, for example, this graph is just a shifted graph of this, and maybe with some vertical stretch as well. This graph with an asymptote right here appears to be like this one, provided we have a horizontal line to which the graph is also asymptotic, and I didn't get that exactly right, a little lower would have been better. This graph looks a lot like this graph if it was just raised up a little bit and maybe moved over this way. Because this graph has an asymptote with the negative x-axis, so we could continue this line here. We continue to get much closer to the x-axis, so we'd eventually just kind of blend with the x-axis. So we'd have a tail in this thing that almost looks horizontal as long as we'd like it to be before it starts to curve up. So this one stays pretty horizontal, then starts to curve up rapidly. So it appears to have the same characteristic that the extended y equals 2 to the x graph would. If this is our asymptote here, then this graph could easily match this one if the x-axis had been shifted, or the y-axis had been shifted over to about here. This graph, well, it's like this one. Remember that shifting and stretching transformations can stretch things by a negative and turn them upside down, and then turn this thing upside down, make it a little wider, a little narrower by an appropriate vertical stretch, and then just move the vertex over to this point, and we have this graph. And similarly, this graph pretty much looks like this one. We would have an asymptote here and a vertical asymptote here. So we can immediately see the stretches that are involved. The shifts that are involved. Now, stretches are a little harder to see, but it's pretty clear that after whatever stretching we need here to turn this thing upside down and make it a little bit wider, we're going to have to move it, well, the vertex. The vertex is here. That's the distinctive point. The vertex on this one is here, so it's pretty clear that we have to move it over this far, so there's the H. And then we got to move it up here, and here's our K. So this would be an AF of x minus h plus k for f of x equal x squared. Okay. This looks like our 2 to the x function, but it looks like it's been raised up and moved over. Okay, now if this distance, we move over until this horizontal asymptote that is, okay, well, the x-axis is a horizontal asymptote here. We appear to have a horizontal asymptote about here, which means that we've moved it up this far, which means that we have a vertical shift of k units. And how far do we move it over? Well, the y-axis here is the point at which the graph is this far above the x-axis, and the x-axis is the asymptote. Well, if we move over to to this point at approximately here, it's this far above that horizontal asymptote. So we're going to say that the horizontal shift would have been this. And maybe I make a better H there. Okay. Now, for this one, again, a little hard to see what the vertical stretch might have been, although we could do that, but let's look at the shifts. It appears that this distinctive point here, the point where the thing goes from being concave downward to concave upward, well, that is something we could kind of call a vertex. And that happens on this graph here tells us that our horizontal shift is probably this, and our vertical shift is probably this. For this graph, we have two asymptotes for the 1 over x graph, the y-axis and the x-axis. So the distinctive point would be here, and that point has been moved over to here because those are the two, that's where the two asymptotes meet. So that again, we have a horizontal shift h and a vertical shift k. And similarly for this graph, the origin, the distinctive point, has moved to here, which means that we've got a vertical shift of k units, and that'll be a negative shift in this case, and a horizontal shift of h units, and then whatever vertical stretch might be involved. I'll say the distinctive things about this graph, there's a very distinctive point on each one of these graphs. And in each case, it's actually the origin, because that is sort of a point of symmetry, or at least a point where one axis of symmetry crosses, and often two. We have the horizontal asymptote, which is going to coincide with the x-axis and this point here. Okay, well then we have the horizontal asymptote and this point here that correspond with what we have down here. Okay, so that's just a visual picture of how horizontal and vertical shifts work, and we've talked about how stretches work.